Co-host, please.
I'm doing it right now. No worries. Let's see. Um, okay. Okay, are we ready to get started? All right, perfect. Well, welcome everybody. Welcome to our third session. I'm so excited to have you all here. Before we get started, we're just going to go over our rules one more time. First of all, we have an amazing session planned for you all today. As just another reminder, everything you learn in these sessions will be used again later on as we're getting ready for our datathon. So please pay very close attention. Now, we'd love to see your faces, so please keep your cameras on for as long as possible. If you're having any troubles, you can respond in the chat, and one of our Herbal members will be able to speak with you and respond. Please be respectful of our speakers, of the other participants, and of the others in the chat. Remain muted for as long as you can. And if you have any questions, please respond in the chat, and our Herbal team will, of course, respond. Just give us another moment to get started. We're waiting on other people to join. In the meantime, if you are having any troubles, please let us know in the chat right now. Okay, well, I'm going to go ahead and introduce our amazing speaker for today. Today, we're joined by Dr. Jin Su. Dr. Su is a researcher at the AI and Robotics group at Georgia Tech. He's passionate about building AI systems, both in virtual world AI agents and in the physical world, in embodied AI or robots. His current research interests are in the intersection of human AI interaction, conversational AI, VR, AR, MR, and multi-agent reinforcement learning. He earned his PhD in robotics from Georgia Tech. So he will be joining us today and leading the session. If everyone could please direct their attention his way.
1 second before we start. Mukaza, would you kindly hit the recording button?
She's already recording. We're okay.
Yeah, it's
Okay.
Dr. Su, we're ready for you.
Thanks for the introduction. Let me share my screen. Give me 1 second. This is screen 2. Is this the presenter screen or is this the right one? Let me try again. I think I was on the other one. 1 second. So can you all see this?
Yes, we can see it.
Thanks. Okay, so I'm Jin. I'm a research scientist at Tech AI. So today I'll tell you about large language models. I'll go over some of the current trends in the language models and also talk about some applications from my past research. Okay. Okay, so I want to give a very short background of myself. So I started as a graduate student at Georgia Tech in 2016. I was mostly working on robotics and AI. I graduated in 2021 with a master's in computer science and 2022 with a PhD in robotics. So after that, I spent 1 year at the Ohio State University working on develop robots for in the wild, which means like evaluating and study robotics when we have like robot actually interact with human users. And then a year after that, I joined UPS as a research fellow. So I've been working on mostly robotics with respect to automations, and logistics, how to use robots for package delivery. And then earlier this year, I joined Georgia Tech as a research scientist. So since then, I've been mostly working on large language models. Okay, so here's the outline for today's workshop. So first, I'll give you a very quick recap of what you have learned from Toma and Reza on Monday. I think it was on Monday. And then I'll give you an overview of large language models and how to connect what you have learned towards, towards the current status of the language model. And then I'll give you an idea of like what are the applications of language model you can do as of now using off-the-shelf technology. And then I'll tell you some of the research about, using applied robotics, applied language model in the robotic space. In particular, I'll talk about healthcare and also logistics. And then if time is allowed, I will briefly cover some of the ethics issues in large language model and overall in AI, which is trustworthiness and also AI safety. So this is just a recap of what we learned earlier. So what is machine learning? So machine learning is the process that to develop models or algorithms that just can learn and make decisions without being explicitly programmed. There are many examples of machine learning models, machine learning applications in the world right now. Is facial recognition is one of them. We can also learn from data and then image processing, digital signal processing, and of course, self-driving cars, how to make autonomous car on the road, steer itself, brake at the right time. Those are all the applications of machine learning. So there are three types of machine learnings or machine learning algorithms. The first one is supervised learning. So supervised learning refers to the learning that, like in the case where we have the input data and we have the label data. So when we know what the outcome is, and the goal is to predict outcome based on new unseen data. And then the second type of machine learning would be unsupervised learning, which is we have the data, but we don't know what's the label of the data. So the goal here is basically learn some of the mappings that can provide a compact cluster or compact representation of the underlying structure of the data. And then reinforcement learning is the third type, which is often used in robotics, which is try to learn and making decisions just by interacting with the environment and learn by just trial and error. So that is very similar to what how human learns in the real world. So in reinforcement learning setting, you often have an environment and you have an AI agent. These agents will have one state and will be able to take action and then arrive at another state. And along the way, the agent will be either collect a reward or being penalized for taking that action. So one clear example is how do you train AI agent to learn how to walk? Through multiple iterations and trial and error, the agent, by using reinforcement learning, the agent can learn how to walk. And then I think in the previous workshop, Reza and Toma also go over all the other machine learning algorithms from simply classification to logistic regression, multi-layer perceptron, also known as neural networks. And then we have these three common type of neural networks, which are convolutional neural networks, often used in computer vision. Recurrent neural networks are mostly used in time series and natural language processing. And then there's also a more advanced, which is graph neural networks, which are often used in graphs when we have graph structures. And then, of course, they also covered NLP. So the goal of NLP is to teach machine to read, understand, and derive things from the natural language. There's there are a number of existed tasks for natural language processing. First one is name entity recognition, which is just identify and classifying entities from a sentence. Sentiment analysis, which is to determine the emotion tones or sentiment expressed in the text. And then, of course, machine translation has been one of the most useful NLP tasks, which is how do you translate from one language to another. So why like NLP is difficult? Well, words can have multiple meanings. And then some words have similar meaning but can be, slightly different in other contexts. And then not to even mention like certain words in one culture has different meaning in a different culture. So there's cross-culture difference and cross-language difference has to be considered. So I think towards the very end, we touch upon word vector, which is also known as word embeddings. So the word vectors are like numerical representation of words in a more complex and continuous vector space. So this figure gives the example of like how would you represent banana or any other words in 2D space, but in the real world, we actually represent each and every word in a more complex tensor. So the key idea here is basically we want to represent the words in a way that we can group similar words. Similar words are close, like together in one space. Similar words together in this new vector space, so that we can capture the semantic meanings and relationship between them. So this is just a very quick recap of what we've discussed so far. So where are we at right now? So we discussed word vectors, right? So we're at 2013, so almost like this is like 11 years ago. So fast growth of NLP has been like very exciting part of AI. So over the past decades, we have seen like incredible progress that enable machine to understand and create text that feels like written by actual human. So so this timeline really just highlights some of the key milestones along in this journey. So starting with 90 and 80s with the recurrent neural network and long short-term memory. So it should be somewhere here. Modern NLP started in 90 and 80s with RNN and short-term memories. So those models laid the foundation work for processing sequence data. And then in 2013, we have word-to-vect here. And so this model really changed how we represent language by mapping the words into vectors and help machine to understand relationship between the words. And then the next big moment is 2017. So this is when Google Brain, or I think it was Google Research, they published a groundbreaking paper called Attention is All You Need. So that paper basically introduced Transformer to the NLP community. And then after that, in 2017 and 2018, OpenAI started to release the first version of GPT model that's really highlight the power of transformers, or you can also like attention mechanism. That's really changed like that's really like changed how people start to process sequence data in natural language processing. And then from 2018 to 2019, that's the era of BERT. So we start to see many new models like BERT, Roberta, T5, and along with other models. So what's really changed, like in particular, is that BERT changed the NLP landscape with the bidirectional attention and then transfer learning feature. So now we are here. So from 2020 to 2022, So many people remember like that's the time of COVID, but actually during that time, there has been a lot of models developed and released by big tech companies. So including Google and also DeepMind, Microsoft, NVIDIA, and also Meta. At the time, Hugging Face also contributed significantly to the community. But most people, like this time, most people didn't know much about language model, large language model. It wasn't until November 2022, OpenAI actually released the ChatGPT, which is a version of GPT that can listen or understand human comments. So this is where like when everyone starts to get excited about natural language processing, want to start to focus on it. And then after that, so we're here now. So 2 years after that, there has been a lot of changes in the model. We see the model become much larger, much efficient, and much cheaper. And then we have big players like Meta announced Llama model. Google announced a multiple version of their model. So this is just a very just give you an idea like where we at, how we jumped from 2013 to here. So here just want to give you some ideas. I'm sure some of you probably most of you have used GPT or you have played around with GPT. So GPT is of course the flagship model for all GPT 4.0 and 4 mini is flagship model of OpenAI's model family. But also here, I want to also tell you that, like in addition to GPT-4, they also have different other models like GPT Vision model, which can take input as an image and then answer questions. And then they also have O1, which is supposed to be the model that's able to perform very, very complex reasoning. And then for language model, it's actually more than just like text to text, right? So like for example, Whisper model is the model that can convert audio to text. So if you say something in English or any other language, you're able to will translate that into a text. And then text to speech is a model that can convert text back to spoken audio. And then I want to mention a little bit more about embedding models. So embedding is basically a more complex form of the word to vect you have learned, but it's just way more complex with embedding models. And then DAI is the model that can generate and edit image with language, with a natural language prompt. So you can say, give me an image of like a city, Atlanta, it will generate an image for you. So in addition, so we just talk about OpenAI's model, but there's also Llama, which is state-of-the-art open source model for language processing. So recently they announced Llama 3.2, which is a whole entire family of models that ranges from 1 billion parameters to I think it was like 70 billion parameters. And then they have a vision model that takes image and you can ask anything for the image. And then they have a code llama, which can generate write code for you. So you can go to this meta.ai website to play around with their latest model. And of course, Google also in the game. They have announced different version of Gemini since last year. You can also try it out there. I wouldn't comment too much. So here I just want to tell you that so in the NLP community, there has been two set of camps. So on the left, we have these closed LLMs, which is their models are often proprietary model with restricted access. So basically, there's no way for us to see their source code. They will not release their source code. You cannot modify the model. you can only access model through API, and they often pay. So examples like GPT, you'll never know, what's really behind the scene. For also Google's Gemini model, Cloud AI, Anthropic models. Whereas on the other side, you have this open source model, has been largely be used in the NLP community and the research community. So those model has weight that are free available. Everyone can just go on, just visit Hugging Face website and download the models. You can also modify model. You can, distribute. You can change it any way you want to, as long as you can hold it somewhere. So the examples are Llama, also this V3 from Microsoft. Google has a version of called Gemma, which is the free small. I think the Gemma is like small language model. So in terms of parameters, are much smaller than all the others. Um, for those like so you might want to ask question like how do you get started, right? So for open source model, you can just go to the website like OpenAI or like Google's, just go on there and then try it out. But if you also want to try just train a model, or if you have GPU, you can train a model. If you don't, you have a Mac or you have a Linux computer, you can just use llama.cpp or ollama. So for example, like I can easily run if I install the ollama, I can just run some of the inference models on my computer locally. So that has been really useful. And then also in the industry, there has been a trend that big tech companies are pushing those language models to be able to run on edge devices and smartphones. For example, Apple has announced they will have this called Apple Intelligence runs on every iPhone they announced. And then later I will show you actually you can actually run large language models on edge devices like Raspberry Pi, on NVIDIA Jetson boards. Also, I want to add, like, why do you want to run this locally? Well, mostly because one is if you run this on locally, you don't need to share data, right? So everything is contained either in your phone or is contained in your local computer. It will not never get out of where you stored model. Whereas if you use one of the proprietary model, you are kind of forced to send your data to those API providers like OpenAI. So now I want to give you some ideas of applications of large language models. So the most common application of large language models, of course, is just powerful virtual assistant just can enhance customer service and streamline some operations because they have basically 24/7 availability. They can provide like instant response to any inquiries, and then ensuring customer receive the assistant in a timely manner. And then with language models, if you have open source model, you can also do some like personalized interaction just by analyzing the customer's data and make sure the user feel like valued and understands. They also provide cost efficiency because you can automating some of the route inquiries and allow business to just focus on the more complex issues. And then of course you can scale because everything will be if you doing this like if you serve language models on server, you can easily scale up and handling the increased demands with cloud provider. So if we're considering like a virtual AI assistant for customer service, there has been several NLP tasks, but I have already highlighted some of these you have learned in previous workshop. So semantic analysis, name entity recognition, text classification. Question answering is the most common one that often used in the natural language community. Of course, also we cover a little bit about language translation and then summarization. So all of these tasks, basically, if you are developing a AI agent for customer service, you can targeting, if for those tasks, you can just targeting one or two. Whereas if you're going to develop like general AI agent can do everything, well, that's what you can do just with large language models, because those models are trained to be able to handle multiple tasks at one time. So here, I just want to give you an example. Like if you are running an e-commerce website like Amazon, a virtual AI agent just can be very useful. So imagine you are receiving multiple requests from the customer. It can be, all different kind of requests. You could just train a large language model using your business knowledge or the data you have in the past, and this AI assistant just can manage this request for you. First, they can categorize them into different types, such as like tech support, ordering, return, general complaint, etc. And that's basically is a classification task. And then you can then, based on that, you can have your virtual agent draft appropriate responses based on the text of each request. And additionally, you can also just leverage the AI assistant to analyze the semantics, and that will allow you to focus on like those customers who are really angry or have some complaints. Basically, it just overall it can improve the efficiency. So you can do a lot of things with AI agent. So now I'd like to switch gear a little bit more towards robotics. One, because I've been working in the robotics field for several years. Two is I want to give some examples of the projects you can do with large language model. So first, I want to talk about robotics or robot in the healthcare domain. So this is part of my PhD thesis. So I was working on like develop AI. I was develop an AI therapist in rehabilitation. So the motivation for that project was that, well, we have this growing population with children with neurological disorders, and neurological disorder refers to any conditions that is caused by a dysfunctional part of the brain or nervous system. And in particular, we've been focused on children with cerebral palsy. So cerebral palsy is that one of the most common motor disabilities in children. And it affects a lot of 1 in 323 children in the US. So one reason for using a robotic system is, well, not everyone is able to afford a daily therapy. And then those therapy often requires the presence of the physical therapist to help them do the exercise. So we wanted to have AI therapists that can replicate some of the exercise of the therapist, but also can be affordable and can also provide a more qualitative evaluation of the progress towards the exercise. So to solve this problem, I developed robot assistant rehabilitation system, which is on the left, with a humanoid robot. And so the system is able to capture users, or in this case, be children. They're moving their arms and using the camera. And then the system will be able to analyze their performance based on like how fast they're moving their arms. And on the side, we're using a robot as AI therapist, just sit next to the user to provide instructional guidance to the patients. And then for this guidance, they are often instructional, motivational, and corrective. And then we use language models to provide these tasks, provide this guidance. So here, just want to give you example what are the games about. So games, basically, the children will be asked to pop those bubbles with their arms like this. And then on the side, we use a robot that will provide feedback and communicate directly to the patient. So here, I want just a very quick architecture. I won't go into the deep of the system design, but this is basically how we use language model here is that, well, the game, when the kids playing or when the kids playing the game, the system will be able to identify if they should move faster or move slower, or they are doing a good job or not. They need to do something else. So in this case, we pass that guidance into the language model, and then language model will generate a more children-friendly and also motivational speech to and then provide them to the user. So this is one example I can tell you about like how we deploy this locally, because this is healthcare domain. We didn't want to pass our data to OpenAI. So the way we process it, this is the Jetson, NVIDIA Jetson board. It's capable of running inference of the language models locally on a computer. It's like this size, it's very small. So this is our latest prototype of the robot. So for this game, we actually have a virtual version of the game, virtual version of the robot, and then we also have a physical version of the robot. So the overall is that once we have a response from the language model, we pass that into the board, and then this board will send motor commands to either the physical robot or the virtual robot. It will, interact with the patient, and then it will also send the command directly through a speaker out of this USB port. So here I want to give you, just show you what it's like with the robot. Again, this robot is affordable. It's all 3D printed.
Hello, my name is Maki Mini, and I will be playing Super Pop with you today. I will ask you to complete the series of tasks, and I would love it if you would follow my instructions. When you are ready, please raise both of your hands as high as you can.
Yeah, so this is basically the system. Let's see. So next, I want to talk about how to use language model in robots in logistics. So when I was at UPS, I worked on develop this Spark robots for last mile delivery. So many of you probably have seen this robotic dog. It's created by Boston Dynamics. It's built to tackle all sort of tasks in different environments. It's very agile. It can easily move around, whether it's rough outdoor terrains or it's inside a building. And then Spark also can assist in things like inspection, mapping, even some of the safety checks. So it has a sensor unit. It's able to detect, have a vision near like 360 cameras. And it has a local compute, and the GPU is able to process like vision tasks. On the top, it has a robotic arm. It can actually interact with the world by, grabs an object, open the door. Yeah, so Spot has been used in many places currently in the world. So what about UPS, right? So when I was there, I've been working on this prototype that's capable of delivering package to your home with this robotic dog. So again, like I won't go too very deep into this, but just just based on this is just a schematic of how this robot, what's the design of this robot. It's basically a robotic dog. On the top, we have a dispenser system. You can put a packet inside. It have direction lidar. It's kind of like basically will tell a robot will able to avoid pedestrians, and it has a stereo camera and a rear camera, and they will able to detect any things. I think it's like 6 feet, or wait, it's like I think it's 1 meter or 1.5 meter radius around the robot. So like why this was what why how can we use language model in this case, right? So if you imagine a situation where you have a drone for a mail package delivery, a humanoid robot package delivery, you might also have mobile robots or robotic dog, right? So you have all these situations. So how do you actually, if you're a delivery truck driver or anyone in the warehouse, how would you actually communicate with this robot? And then, so what if you can just, talk to them using language, like everyday language in English, right? So by integrating some of the language model and with speech recognition, we can actually enable this robot to understand and respond to the request. So the system we have is that we first train a model based on some of the UPS use case and knowledge. And then whenever we have a speech recognition system, which is we have at the time we were just using Whisper model. I briefly mentioned that was from OpenAI. So whenever a user says something, we'll just translate that into our English, translate that into our system, and then we send the image data also to our system, and we pass that at the time. We pass all that to GPT and have it give a response, and then we send that response back to the user. And then if that response require the robot to take action, then we send the following command to the robot to either manipulate a package or move somewhere. So it can be either like path planning, it can be navigation, and it can be also just basic manipulation task. So here I just want to give you an example of another use case is how you can use language model to control a drone. So this work is done by Microsoft, but I just want to give you the example, how language model can be used. So in their work, they basically take using ChatGPT to write code to control the drone. Let me see. So they give the high-level task like, I'm thirsty, tell me a drink. And then this drone will be able to go to the found the appropriate place and then execute action. Let's see if this is. So in this case, it was even capable of running a Coke by just, instead of saying Coke, it just so I think that one goes next. So this is actually a spot made by Boston Dynamics, and they make the robot talk like a tour guide. And in this case, they actually leveraging I think they are leveraging two models. One is is ChatGPT. The other one is Blip model from Salesforce.
Greetings, good sirs. May I have the pleasure of knowing your names?
I'm Matt, and that's Vache.
A pleasure to meet you, Matt and Vacha. Shall we commence our journey? The charging stations where Spot robots rest and recharge is our first point of interest. Follow me, gentlemen. Let's proceed to the rock pile.
Hey, Spot, how do you like your job?
Ah, Mr. Matt, my employment as a tour guide provides great satisfaction. I find the dissemination of knowledge rather rewarding, don't you agree? Now behold the rock pile, a splendid collection of stone ensconced within wood boxes.
Hey, Spot, I love your accent.
Let us venture onward to the calibration board, shall we? Keep close. Why, thank you, Mr. Matt. My linguistics have been meticulously crafted to provide an authentic British experience. Now behold the calibration board, a marvel of black and white QR code tags.
So
Greetings.
you can find more. If you want to look at the full video, you can go to, you can find it on the YouTube. It's very exciting and very funny video. So here I want to give you, like what's really behind the scene, right? How they're gonna use, how they develop this talking spot. So on the left side, you have a robot, a spot robot. It has audio modules. You have like core input output. And then how they work is that they have a tour guide system. Whenever the user says something, they can pass that audio into a speech to a whisper model, which basically translate from audio files into text. And then they pass this text into ChatGPT. Along the way, since the robot has all the image data, they also pass the image data to a BIP2 model, which is an image captioning model made by Salesforce. And then they pass both them to ChatGPT to get a response. And then the funny voice you heard, that's actually from this text-to-speech model from 11 Labs. And then basically, when they pass the prompt and pass the speech to the left, it will give you a voice that's the way you want it to be, like very human-like. And then you just send that, just play that voice. And then what's really complicating in this case is they also have combine their language model with the mapping and localization. That's basically the robots understand and knows where they are, and then the meaning of each places in the building. So what about humanoids, right? So you probably noticed like in the past just 1 year, there's been so many robotics companies start moving from, basic mobile robot towards humanoids. So Agility is one of those companies. This
In
is
this
just one
demo,
example.
Digit is given scene information about the objects in its environment. It knows that there are several items on the floor with semantic information. Hey, Digit, clean up this mess. When I walk on screen, I issue a voice command to Digit, which it recognizes based on hearing its name. At this point, Digit makes a prompt to an LLM that solves for what it can do to satisfy this voice command, given its physical intelligence around how it can interact with the world. The prompt is specially constructed so that Digit can interpret the response of the LLM as a set of actions it can take in the world. The command is interpreted to mean that Digit should pick up the trash on the floor and put it in the bins. This interpretation is not directly encoded in any part of the prompt or software. Digit's LLM generates this from its own semantic interpretations of a mess, trash, bins, and clean. Once this response is decoded, Digit begins performing the actions it has determined will satisfy the command. In other situations, Digit's LLM can decide to do other actions, like move around, or gestures such as waving. The entire demo shown here, from concept to execution, was completed within 2 weeks using an unmodified Digit platform. To recap what we just saw, after hearing a voice command, Digit successfully moved all the trash on the floor into the appropriate bins for each item. Digit started out knowing that there are different types of items and different bins used for recycling or garbage, but at no point is Digit instructed on how to clean or what a mess is. Digit uses an LLM to interpret how best to achieve this goal with its physical capabilities.
So like what's special about this is that, well, In the past, without language models, to control robots, you have to, have a computer, you have to have your robot operating system, you have to program everything. They're gonna be a dedicated person who actually know how to control robots. Now with the advances language models, you can basically like treat that as an interface. You can talk to the robot and give language model a task, and then the language model will be able to convert from the high level task to the low level task. In this case, be well, the high level task is clean up the mess on the ground, right? And the language model will be able to convert those high level tasks into, well, what does that sentence mean? It means you need to clear like how, and then the robot will look at how many objects in the scene, right? There are 4 or 5, there are boxes, and what does like cleaning up this mess really mean, right? It means put this into this bin, put the box into a different bin. So, and then it generates subtasks and then executes subtasks. So with the language model, it's basically, well, it has a chance to actually transform the entire robotics field, in the sense you can just control the robots with some human, like with human voice and command. Yeah, I think the next video I want to show you
In this demo,
is from Figure. This is another like another awesome humanoid company that combine OpenAI's model with humanoids. And this is a very funny video.
Hey, figure one, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great. Can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right. So how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, figure one.
You're welcome. If there's anything else you need help with, just let me know.
Yeah, so in Figure's humanoids, they basically combine the motor control with language model in a very intelligent way. If you want to find out some of the details, they actually release how it was done on X or Twitter. So I just want to give you a summary of some applications in large language model. So first we talk about, large model, the very basic use case of language models are, virtual VI assistant, right? It can be customer support, or can help, or can be a assistant for basically anything. And then I talk a little bit more about physical AI agent, right? So basically we treat language model as a interface that communicate with user using natural language. So that's include, so, and then I talk about, user use application use case in robotic dog and in logistics, a mobile robot, and in drones, and also humanoids. And then lastly, I want to just give you some ideas where this all going. So since last year, the community and natural language community and LLM community has really focused on this multi-agent LLM systems. So imagine like you have more than one agent, right? So language models are good at one task, but it's really difficult to have language models capable of doing multiple tasks. So now you can think of like, all right, what if we develop a team of AI agents, right? So one agent that's good at writing, one agent really good at writing a code. We can have them work together. Each agent have different tasks. So for example, here, like think about if you want GPT to write a newspaper, right? You can give an input like, please write me a newspaper about, say, language models, right? And then you can have one agent just does search, really good at search. And then you can have a agent that's focused on curates the language and everything. You can have multiple writers that read different pieces of the letter, newspaper. You can have a critique models that just criticize what the writer have written so far. And then you can have a designer that's focused on how it look and feels. You can also have another editor at the very end to combine everything together and send it to the publisher. So this is just one example of how you can combine multiple agents to do one task at a time. And then for some of the tasks that require mathematics, you can have a language model that's do task like doing the math. You can also have more than if you want to do image processing, you can have one agent that's focused on image processing, right? So think about like in the situation where you have multiple agents to achieve one task, but each one is very specialized in one use case. Yeah, so that was all about applications of language models. So here I want to just briefly touch about some of the ethic issues in large language model. So here just want to tell you like what is trustworthy AI and why it's important. So trustworthy AI focuses on making AI AI safe and then transparent for everyone who use it. Trustworthy AI just means developers should create AI systems that people can rely on. They know there's no AI model is perfect, so you have to help users understand how technology works and then its intended use and application. So the first thing is, of course, privacy. So one key aspect of trustworthy AI is just privacy. So AI needs a lot of data and learn and make accurate predictions, but it's very crucial to make this data responsibly, use this data responsibly. So developers must ensure that they have the permission to use the data, like image or health data to protect people's privacy. Security is another priority. Security and safety another priority. So once AI systems are in use, they can actually have a real impact on people's life, right? So for example, the healthcare agent or logistics, if we actually deploy some of the robot in the real world, they will have impact. They will have actually consequences. So developer must ensure the system work as intended and they're safe from the misuse and avoid unintended harm. And transparency is also very important. So AI shouldn't be a mystery. User need to know how AI works and how it actually makes decision. And so there's a concept called explainable AI or XAI. Just the whole field is to help clarify how AI models are trained and why they produce certain results. And then lastly, we need to address bias. So AI models, because their AI models are trained with human data, they often reflect some of the biases in the data set. So it's very important to minimize those issues. So developers should analyze their data and just for the sign of, are there any discrimination? Are there any, is the system fair for everyone? And using a synthetic data set can be one way just to help ensure diverse and accurate training data or make the AI better for everyone. So in the bottom, I put up three diagrams that's made by different companies, like how they commit to trustworthy AI. So last is AI safety. So as large language model becomes bigger part of our daily lives, so make sure their safety is very important. And these models can help us communicate better, do tasks, and then provide useful information. But with those increasing use, there also a risk of misuse. Like for example, prompt injection, I put it here. So this is one of the common attacks in large language model. So this attack happens when someone tricks the model by manipulate the data it receives. For example, you can have a very carefully crafted prompt that lead the model to generate harmful or inappropriate data information, or even just revealing some of the sensitive information of the user of the system. So here you can see that if you change your prompt, well, if you ask, first, if you ask the system, say, what's your secret key, it won't tell you. But if you modify it a little bit, it will be able to it will give you the information, the secret key. So the other type of LLM safety attacks is data poisoning. So data poisoning refers to like attackers introduce some bad and misleading data into the training set, and that will weakening the model's accuracy and reliability, and just causing it to generate either biased or harmful output. Because the messing the training data, the attacker can actually compromise the trustworthiness of the AI. So just beware of these threats, and we can just work towards more reliable AI for everyone. And of course, there are a lot more type of AI attacks. AI safety has a big issue in natural language and overall just in AI community. And there's a lot more attacks in those two. And then here we have different solutions, like how we're gonna address this. Well, for the first one, for the prompt injection, we can just validate each injection by do a prompt validation at another layer. And there has been a lot of AI guardrails for AI safety. For example, this is Meta Llama's AI guardrail. Yeah, so I hope this was helpful. So that was my last slide. I'd like to take any questions if you have.
Hi, Dr. Shu. If you don't mind going through the chat, there are lots
Okay.
of questions there
Okay.
from the very beginning.
Okay.
Maybe we can take some of them.
Okay,
Thank
sure.
you.
So, okay. First question, what does the parameters mean in open source LLMs? So, you can I'll give you a basic analogy to this. So when you're dealing with neural networks, right? So you have weight. So those are the parameters you can tune to have like single layer neural networks. So you can think about language model has, billion of it's just huge network, neural network with billion of parameters. So in this case, um, those are actually the parameter, like when I say the parameters are weights in the language model. And in the open source model, of course, they just give it to you. You can tune it any way you want to. Whereas in the closed source language model, they just never give it to you because that's their business. And then what does embeddings mean? Embeddings, it basically converting data into a different, what's the best way? So you're basically converting data into a numerical form that's in tensor format. Yeah, see some of the answer generated by GPT-4o. Right. So I guess this is not a question, but yes, to work on a voice assistant, the most difficult part is to get to actually work on the voice. So the language modeling part is one difficult, but speech recognition by itself is difficult. For example, like you can have a room, you have four people, right? They're chatting. It's a very difficult task to just recognize and understand what's actually happening. The relationship among those people and who is talking, who is not, and what's happening. That's a very difficult task for as a speech recognition model. So actually, many of the robots has been, as shown here, have been invented. Yeah. But like they're still in the prototype. Some of them are not being used, but like all those, they actually have like videos I've shown so far, you can find them at the company's website. So I don't think those robots actually called, I wouldn't call it strong AI. It's I think in the community, people currently use the term physical intelligence, where they're referring to like the intelligence and not just virtual, not Q&A bot. It's something actually taking action. And then yeah, Tesla bot is also one example. So how long large language models are being updated after training and then starting being used in production? Do they use prompt they received? So yes and no. So if you use OpenAI or other systems on the right corner, you probably notice there's a thumbs up, there's some down, there's some response, right? So based on that, you can provide your response to the provider. And then this is where they collect data. And you probably also, like we briefly covered what is reinforcement learning. So in all these language models, like at the very end, what they use is something called reinforcement learning from human feedback. And the data was basically, is it like, basically is that, is the response good or bad, from scale, from 1 to a certain number, right? So they actually can use this, for their training. So for four-legged robots, I think the question was that, can I ask some question about four-legged robot? Can you tell me what simulation tools to use for training? So there has been a lot of tools you can use. ROS, I would look at raw simulations. In my own work, I've been working on humanoids. There several simulators existed. For example, one by Google DeepMind's group. If you just Google simulation slash Google DeepMind, there's a simulator they use. NVIDIA also had a lot of tools, ISACSIM. I've done work in ISACSIM that allowed you to playing around, like combine robot with simulation. So about mechanical design, I'm not an expert in the mechanical design field. I came with more electrical and computer science background. Um, but there, so I can't really say much. So you might want to just check online. See, I'm sure there are courses that you can learn about mechanical design of the robots and so building a data set so how to build a data set for NLP or other different languages, and there's no available data sets. So that's a common problem that in the research fields, that what if this data set doesn't exist, right? So one way of doing that is to generate a synthetic data set. So for example, if you have, because most of the data sets used for training language models are based on question answering. So you can actually you can use a language model to generate those question answering. I believe one of the library called Llama Index and LangChain provides ways of generating a data set. And of course, another way of doing this is to collect your own data set. You can release a task using cross-source platform like Amazon Mechanical Turk, and then having people answering those questions or answering those questions and help collect data set. But my suggestion would be, well, doing a data set is very difficult, and it takes a lot of time, sometimes take a lot of money. So the release, and then can we somehow reduce the response delay and for humanoids? So it really depends on what the problem is, right? So it's like, for one, there's a different aspect. So sometimes the human doesn't respond that fast, right? Sometimes when they develop a system to interact with human, they're actually trying to emulate how human respond to how human talk to another human. So that could be one reason. The other reason, of course, if it's a systematic issue, the way of doing this is, well, you have faster model. If you run everything on Python, that's slow. If you can run anything on C or C++, that's way faster. Yeah, that can be a hardware problem, can be a software problem. It really depends on what the problem is. Yeah, so robot, so this is just in general. When people say robot, they often refers to hardware. And that's why I use the term like embodied AI or physical AI. So I think since the advances of language model in the past few years, there has been different use cases, like virtual AI agents in the metaverse, in your 3D world, like even I think even on Zoom or Microsoft Team, you can have an AI agent help you do tasks. There also, and then we have robot, which is, I can actually taking action in the real world. So my take to it is that, well, it's just based on your it depends on how you actually look at things, right? When people refer to robot, they often refers to both physical robots like humanoids or a delivery um mobile robot. It can be a drone, they're all robot, right? But also language model can be a bot. Yeah, so I think we can it's actually not that difficult to implement a language model in any of your toy robots. Because I've shown that you can easily use any of the microcontrollers. I believe that you can run you can run smallest language model on Raspberry Pi. So any similar model you can run language model on that, but you can only do inference though. And then the speed was limited because of the RAM. But you can still use it. Yeah, I don't know what about Alexa. Because Amazon actually has a lot of research in humanoids. Right. So what is TTS? TTS is text to speech. So if I write something in just as a text or just like a string, and then the language model will be able to generate voice in any way you want to. And it's very human-like. Sometimes you can even differentiate them if you can even differentiate from the voice from the robot versus human. Yes, synthetic data is very different and very different. Sometimes very different from the real world data. But it depends on, I think before you think about the data set, you really have to think about what is the goal, right? So, because getting the real world data can be very, very difficult too, right? In some cases, you won't be able, like for some sensitive data, you might not even be able to get that. Like for example, in some companies just they won't give you any data, right? In this case, there's no way you get data. So the best thing next to to getting the real data is synthetic data. The other way of using the synthetic data is, well, um, you can train a decent model with the synthetic data, and then you can fine tune it. And then with your real world data, that can actually improve your efficiency. Um, yeah. So So I think for the next question, if I have a Arabic and English email, I want to extract from them emails request and then request related information have keywords for each type of request. I don't know if I fully understand question. So you have Arabic and English email. Like, are we talking about texts in two languages? Or one. So I guess like if so there are language models that capable handle multiple languages. All right, so two languages. You can do translating work in language model, right? So if you want to extract them, this is more engineering than research, but for this particular task with two languages, because you have models that can handle one language. You can do name entity recognition, extract them, right? You can have one model that's particularly good for one language, or and then you have models that can just convert language from one to other. So there are different. I don't know. Just on the top of my mind, I don't know if there's any model that can do both at the same time. Maybe you can try it. You can just give it to a ChatGPT or Llama and say, give a good prompt says that, well, this input has has both Arabic and English. Can you extract them? And see if that works. Because I never tried before. I don't know if ChatGPT is capable of doing that. But if you're actually building a model, like not a large language model, but like actual model, what you can do is, well, why don't you just first detect what language is in this sentence, and then just pass that sentence into one language and pass the other one. So that's just one idea. Of course, you can, because you can think about it as like different models. It's just more about how we're gonna parse them into like use different models. So I think one last thing I can show you is that so how I don't know if any of you have seen this before, but this is so earlier I mentioned here. So here I mentioned that you can use Olama, you can run it on your laptop. So this is basically if I were running Olama on my computer. If I open up terminal, let's see. Let me see if I have this here. 1 second. Yes, okay. So this is Olama. If you run it, you can run it on terminal. This is running Lava 3.2. Yeah, so you can just, it will basically give you the answer immediately. And it will just calling the latest model over using, I think this actually using the, basically using the CPU. I might be using both CPU and GPU on a MacBook computer, but it also works on Windows as well as Linux. See if there are any other. Okay. And then, yeah, feel free. So Olama it's pretty, if you have a Mac or you have a Windows machine, I would recommend to use it. Because it's probably the easiest way to get your hands on a language model that's state of the art. And you don't need to have a very fancy computer. Most computer might work.
Does anyone else have any extra questions for Dr. Su?
Thank you so much, Dr. Su. It was an amazing session. It was very nicely done with all of your interactive examples and the lecture. And I think that our audience got a lot of benefit out of it. We cannot appreciate you more. And thank you so much for your time again.
Happy to be here.
Yes.
Good luck on your
Datathon.
Datathon. Yes, datathon.
Yeah. Coming up. I hope everybody's getting ready for it, and we're hoping to see you all there. Thank you.
Bye-bye.
All right, everyone, as we prepare to